Okay, at this point, you should already have these functions graphed. Oh, I should have the... Hang on, let me pause. Quiet, please. So, for this first one, I showed you that you could you have to pick some... Oops, that didn't work. You have to pick some number here. It's still not very good. Any number for your constant, C is going to be a horizontal line at whatever constant you chose, right? So any number for that constant is the number that you choose. Then the y-intercept is going to be where? Where is this crossing the y-axis? Mine is crossing at 3. Yours will be at whatever location you chose. So for me, the y-intercept is 3. Is there an x-intercept? No. So for there's an x-intercept, you can write none, or you can write NA. It's not applicable. Either answer is okay. Now, the domain represents all of the x's that are being used with this graph. So if I'm looking at this graph, and I'm looking at all the places where this graph exists. So if I just shaded this everywhere the graph exists, and it's going to go from left to right forever, right? So what will be the domain of this function?
Negative infinity and positive infinity?
Yes. So in interval notation, that's from negative infinity to positive infinity. What will the range be?
Oh, I was looking at your pencil.
What y value is being used?
3.
3 is the only one that's being used here. Now, in the generic form, that's y equals, it's whatever number you chose, right? So whatever number was there for us, it's y equals 3. Or for mine, it's y equals 3. If you drew yours differently, then it's whatever number you chose. So then in inequality notation, this is negative infinity less than x less than positive infinity. I need to zoom in or something. I can't write that small. Let's see. Can I? Oh, that doesn't work. Thought there was a zoom on this thing, but I don't see it. But for the range, there's no inequality. It's still just y equals 3. Or C, whatever C you chose. For my graph, it's y equals 3. If you drew yours at -4, it's y equals -4. Wherever you drew your graph. And then in set notation, I'm really going to have to zoom in on this. That's not working. So we'll just resume. All right. For set builder notation, I'll zoom in closer on the next one. It's this. It's the set of all x's such that well, let's do it the shortcut way, such that x is an element of the reals. Now, you could also put the inequality there with the negative and positive infinity if you want, but when it is all real numbers for set builder notation, it's okay to do it this way. And then the range will be the set of all y's such that y equals, for me, it's 3. C, whatever value of C you have. There are no asymptotes, and we have our graph. So the function f of x equals x. That's your diagonal line through the origin. That's what you should have graphed. So where does this intercept the y-axis?
0.
At 0. And where does it intercept the x-axis?
0.
0. Now, sometimes I ask you to give me these as an ordered pair. Sometimes I just ask you where it is. This particular paper did not specify that. This paper did not specify that you give it as an ordered pair, so we're just going to talk about where it crosses the x-axis. So, what is the domain? If I try to shade this in, everywhere this function exists, what x values will be used? Infinity, right? Because this arrow indicates that it's going to the left forever and to the right forever. So my interval notation is negative infinity to infinity for domain. It's also going down. As it goes to the left, it's going down forever. As it goes to the right forever, it's going up. So that's our range, which is negative infinity to positive infinity. So our inequality is negative infinity less than x less than infinity, and negative infinity less than y less than infinity. Then set builder notation, again, set builder notation domain is the set of all x's such that, and normally you copy the inequality here. You may copy the inequality here if you wish, but it's actually a little shorter just to say x is an element of the reals. I don't know if I can get rid of that little dot. Nope, not without messing up everything else. And the same thing for the range. The set of all y's such that y is an element of the reals. Please pay careful attention to this. In both of these inequality notations and set notation, if I'm asking for the domain and you put a y in there, it's wrong. If I'm asking for the range and you put an x in there, it's wrong. So make a special note that the x and the y has to be in the correct place, right? Here and here. So make yourself a note to that, so you'll have that correct. And no asymptotes in this one. So our next graph is the absolute value. The absolute value graph is the linear graph. It's this straight line, except what we did is we took all of these negatives, all of the negatives that were over here, and the absolute value changed them to positive. So that's what gives you this V shape for the absolute value. So where's the y-intercept? 0. And the x-intercept?
0.
Also at 0. Notice on this paper it says the x-intercept, in parentheses it says 0 or solution. Those words are synonymous in their meaning. We use them differently in different contexts, but whether I say x-intercept or whether I ask you where are the zeros or where are the solutions, all of those things mean where does it cross the x-axis. So domain, it's going to the left forever and the right forever, so what is the domain?
Negative infinity.
Negative infinity to positive infinity. And the same with the inequality. But what about the range? Will this function ever be down here?
Nope.
No, it will not. So where does the domain, the range start?
0.
It starts at 0. Is 0 included? Is it touching 0?
Yeah.
So we need which kind of bracket or parentheses? Bracket, because it is included. So the bracket, the 0 is included, and then from there, where does it go?
Infinity.
infinity. It goes up forever. So we're going to positive infinity after that. So then for our range, which symbol do we use after the 0? Less than or equal to. And for your inequality, it's okay to stop there. It is also okay to write y greater than or equal to 0. Those mean the same thing. It just doesn't match your interval notation as well. It is also allowed if in this top one you could also say less than infinity. Just be sure you don't put a less than or equal to bar. Just less than. So then in set builder notation, we're still at the set of all x's such that we're still all real numbers for the x's, so we can just do that. But for the y's, the set of all y's such that, and 0 less than or equal to y greater than or equal to 0, it doesn't matter which one of those you put here as long as you have them. And you don't need the less than infinity, but it's allowed if you want to put it there. So any questions about any of these? So next class, I'll give you a quiz to see if you have these memorized yet, because I don't know anything else for you to do except to memorize them.
I can just tell you.
Right? If you memorize what the graphs look like, then giving me the domain and range shouldn't be a problem if you know how to find domain and range, because you know what the graph looks like. But otherwise, the name of the function, the equation for the function, and what the graph looks like, those you have to memorize, and just you have to know those. You will be using these parent functions all of this year, all of next year in pre-cal, and into calculus. So you need to just memorize these now, and then you got it. Okay. Do you remember what the quadratic shape is called? It looks like a U, but what do we call that? A parabola. So the shape is called a parabola, but the name of the function is actually, the name of the function is actually quadratic. Oops, I didn't touch the origin. Okay, something like that. So this parabola, even though it's a U shape, it will forever get wider and wider and wider. It looks skinny, but it's still getting wider and wider. So eventually it will use how many of the x values? All of them. Yes, I heard someone say all of them. So our domain then is all real numbers, which is negative infinity to infinity. But what is the range?
0.
0. And which kind of endpoint? Parentheses or bracket? Bracket. Because it is touching, and then it goes to infinity. So all the y values are going this way. It's going up forever, but starting at 0. So in inequality notation, negative infinity less than x less than infinity. For the domain, for the range, again, 0 less than or equal to y. You could write y greater than or equal to 0, and it's okay if you put 0 less than or equal to y less than infinity. It's okay if you do that as well. In our set notation, the set of all x's such that x is an element of the reals. That covers all of the reals. That's not a very good brace. I didn't want that. Our range is the set of all y's such that y is greater than or equal to 0 or 0 is less than or equal to y. Those are mathematically, they're interchangeable. I usually go left to right just to help you get into the habit that all the intervals must go left to right. But just to show you that it can be either way. Questions? So the square root function starts at 0. I don't want to select, I want to draw. Trying to make a dot there, and it keeps wanting me to select it. And then it goes this way. Now, it looks like it isn't getting taller. It looks like it might be approaching some number. But in reality, the square root of anything, the bigger the number gets, the larger the square root gets. So the domain is going to the right forever, but the range is also going up forever. But only starting at 0 because we don't have square roots of negative numbers, right? So both our domain and our range start where?
0.
And included or not included?
Included.
Included. So we go from 0 to infinity for the domain and from 0 to infinity for the range. Please remember that you only have parentheses next to the infinity symbol. For our inequality notation, I can write 0 is less than or equal to x. And again, if you want to put less than infinity, that's okay, but that's optional. And 0 is less than or equal to our y's, and that is sufficient. The set of all x's such that x is greater than or equal to 0, and the set of all y's such that y is greater than or equal to 0. Okay, so cubic, mathematically, we write it as x to the third. On a calculator that doesn't have that button, a button for that, you would put caret and then a 3 in the exponent, for the exponent field. So this function actually looks like a parabola that you've twisted and made skinny. It goes this way, and it goes this way. So notice the curvature here looks like a parabola. It starts to go out, and then it doesn't get exactly straight, but it has this curve or this bend to it right at the beginning, and then it just sort of smooths out after that. So this is cubic. This function, even though it doesn't look like it, it looks like it's very skinny. It's obvious that it's going up and down, right? But it's also, as it's going up and down, it's also getting wider and wider, just very, very slowly. So what will the domain be? I think I need to get my list and call on people. I'm not sure where you are.
Negative infinity.
Negative and positive infinity, right? We're going to use all the x's. It's eventually going to get as wide as possible. So the domain for this is negative infinity to positive infinity, and it's going down forever and up forever, so that's also negative infinity to positive infinity. Okay, I'm going to leave the inequality notation and the set builder notation to you for now. I want to be sure we get through this, and we have a couple other things we need to do before time to go. So I'll let you fill those in. All right, the cubic function is this we've just drawn. The cube root function is the inverse, and I need to go back and give you that as well on which ones are inverses of each other. These are inverses of each other. What that means is that these are going to be a reflection across the line y equals x. So if I draw the line y equals x here, and then I reflect this function across that line, so that every point that's up here, I reflect it across the line y equals x. So I know that the cubic function. So if I have 2 cubed is 8. So I know that up here somewhere, I don't know exactly where it is, I know that the point 2 comma 8 is on this function, so that on my other function, I know that there's a function 8 comma 2. Let me switch to another color. So I know that 8 comma 2 is here. I know that 1, 1 is still here, right, is still here, and that it still goes through the origin. So I'm going to end up with something that looks, oops, that's too skinny, right? If I take these values and reflect them over to this side of that line, it's going to end up looking something like this, right? Which is what we draw here. So we know it passes through the origin. We know that 1, 1 and negative 1, 1 are still in the function, but now I know that when I get out here to 1, 2, 3, 4, 5, 6, 7, 8, I'm at 2. So it goes this way, oops, and this way. So that's my cube root function. And hopefully, the next thing we're going to do is inverses. So in next lesson, we'll be looking more at this, reflecting it across the line, y equals x. But that's how I know it's cube root, is because it looks just like the cubic, except that it's been reflected across this line, y equals x. Has the domain or range changed?
No.
No. Still going left and right forever, still going up and down forever. So again, I'm going to leave the other 2 notations for you to fill in. Because I do want you to get your Chromebooks and do your Desmos activity today. Anyone not finished with this? So depending on what base you chose, if you chose 2 to the x or 3 to the x or 4 to the x, it will affect your graph a little bit, but not a lot. Since I have 2 to the x is what I have written here, then that's what I'm going to draw. Every exponential function that hasn't been transformed, it hasn't been moved to some other place, will always cross the y-axis at 0, 1. So there's a critical point, 0, 1, because anything raised to the 0 power is equal to what? 1. So any base, doesn't matter what the base is, when x is 0, we're raising it to the 0 power, it's equal to 1. So the y-intercept is always going to be at 1. So my y-intercept here is always going to be at 1. Right. And to the left of this graph will approach 0, but it will never be 0. So there is no x-intercept. It will never touch the x-axis. Then the next critical point that you will always have is when x is 1, whatever number you chose as your base, that point will always be in the graph. So if I chose 2, then when I go to x equal 1, my graph is going to be at 2, because 2 to the 1 is 2, right? If I chose 3, 3 to the 1 is 3, so I would have the point 1, 3. If I chose the point E as my base, then that 2.71828, then that would be 1 comma that would be on my graph. So I know I'm going, mine's 2 to the, I'm graphing 2 to the x. You could have chosen 3 to the x or 10 to the x or whichever, and that would affect how sharply this turns up for the exponential. So even though it's headed very steeply up on the right-hand side, it still is getting wider and wider and wider, right? So there's no vertical asymptote. none, or you put NA. There's no vertical asymptote. It will still get wider and wider. So what does that make the domain? Negative infinity to positive infinity. Thank you. Okay, some of you up front need to answer. These guys back here are answering all my questions. Otherwise, I'll get my random number generator and start calling on you. The range, however, none of it is below 0, right? What did I just tell you about what's going to happen? Is it ever going to be 0? No. So what kind of symbol goes before the 0? Parentheses or a bracket? Bracket means it's included. Will it ever be 0? A parenthesis, yes. So it won't ever be 0, so you need a parenthesis next to that 0, and then it's going to infinity after that. And these two values, these are critical points. These are called critical points that will be on every graph. Now, as the parent function. They'll still be there, but when the parent function moves, they move with it. Right? So just to make sure on your inequality notation, the domain is still the infinities, but the range needs to be 0 less than y, not less than or equal to. Or you could write y greater than 0, but no equal bar. So exponentials and logarithms are inverses of each other as long as you have the same base. They will be a reflection across the line y equals x. So that's the one I'm going to draw because I drew it here. But if you put it on your calculator as just log of x, then you're going to draw, yours will be drawing base 10. The only difference is this critical point. Instead of this one is 1, 2, mine will be at 2, 1. If you did base 10, yours will be at 10, 1. So we're going to reflect that. We're going to cross. Our critical point here is going to be at 1, 0, and whatever our base is, comma 0. And so this will approach the the y-axis, but it will never touch the y-axis. And then mine is going to be at 2, 1, and it goes this way. On the calculator, at least on the TI-84, I'm not sure about Desmos, this function looks like it just goes right over there to the y-axis and it stops. That is not true. These calculators are old. They don't have nearly as much memory as your phone does. They don't have the capacity to calculate the precision needed to draw that graph all the way down next to the y-axis as it should be. So just be sure when you're looking at this graph on the calculator that you remember that it continues down forever right next to that y-axis, getting closer and closer but never equal. Questions? All right. So on this case, my domain is 0 to infinity, but with the parentheses, right? Because it's not included. It won't ever be, x won't ever be 0. But my range is negative infinity to infinity. Oh, I get this Desmos done. I don't have time for a hurry. This one is called the reciprocal function, or the rational. This is rational when we're talking about the general form for all equations that have the variable in the denominator. It's called the reciprocal specifically when it's 1 over x. But for the most part, you'll see those two words used interchangeably. Not exactly correct. This is the one that has two branches. It goes this way and this way. And it goes this way and this way. That's supposed to be a curve, not a square. Although it does go through the 0.11 and -1, -1. So for this, oh wait, I forgot something. All right, I'll do it when I get done with this. For this, we have both a vertical and a horizontal asymptote. So if I look at here, this line is the line x equals 0, which is the y-axis, and it will the function will never touch. So we have a vertical asymptote at x equals 0, but we also have a horizontal asymptote here. This is the line y equals 0, which is the x-axis. Those are our two asymptotes. The function will never touch either of those axes. So we have to do something with our notation. Our function will keep going to the left forever. So we know that the domain starts at negative infinity. But it can't be equal to 0, so we have to stop there. And then we'd have to union that with skipping across 0 and going to positive infinity. So you need to be sure that next to the zeros you have a parenthesis, not a square bracket. And the same thing is true for the range, because it's also going to skip over 0. So then for the inequalities, we have to use the word or. We have the x's that are less than 0 or x's greater than 0. Notice the U is in the interval notation, the U symbol. The word or is in the inequality notation. And the same is true for the range. The y's that are less than 0 or the y's that are greater than 0. You do have to write these separately. You can't put y in the middle and have the symbols going opposite directions in one sentence. You have to have two parts to the sentence. And then the set notation, you just put those inequalities into it. Anybody still copying these? All right, let me go back up just a bit because I didn't have you put in the asymptotes on these two. So the exponential graph was like this. It does not have a vertical asymptote, but the horizontal asymptote is the x-axis, which is y equals 0. Here, this is line y. So this is a horizontal asymptote. And on the log, the graph looked like this. There's no horizontal asymptote, but there is a vertical one here. I didn't draw that very well. There's a vertical one, so it's at x equals 0. That's an equal sign. Oh, attendance. Okay. All right, I'm going to let you fill in the rest of those blanks before next class. I need to talk to you about what we need to finish up. So all three of my commuters came in, right?
You sound like a ritual. You are summoning the devil.
Give me your cheer. And
Can the lights start flickering? This can't watch this class. I'd rather be in Wisconsin, honestly.
Alright, I'm sorry about so much listening. I'm working on your videos, getting your videos ready so that you can do this where we don't have to just sit and do this in class. We can do more interesting things. We have 20 minutes. I don't know if we can get the Chromebooks out, do something with them and come back.
Okay, everyone else.
So we have to quit.
They're like excited to be here. They're like, oh boy, I'm ready to learn.
Ready to learn, guys.
Oh.
Okay. This paper is a homework assignment for next class. The first part, these first 4 questions, this is just something else to review from Algebra 1, just to make sure that you remember how to solve for x. So you're going to solve for x and get a value. Please show your work as you do that, so don't just write down the answer. Write down the steps that you have to take for those. Then parent function, 2 parent function questions on the front. That's the sort of thing that you need to know. Also, on the first 2 on the back, notice I've given you an equation. The equation I gave you is not the parent function. I mean, yeah, it's not the parent function. It's the parent function that has been transformed, and you have to tell me what its parent function name is. Right? And then what is the equation of the parent function. Okay? So for doing this homework, you can use the chart we just finished. Then in your own words, define domain and range, and then give me the domain and range of the things that are drawn here below. Now, the one on the left is pretty straightforward. The one on the right is actually a triangle, not just a graph like what we've been doing here. So it's a closed shape, but it still has a domain and range. So notice at the bottom that the point at the bottom has an open circle. So even though the V part connects,
It keeps going.
they're all connected.
You're welcome.
I'll wait.
I'm ready to go. 15 minutes.
Okay, so any
I had debate
questions
last
about
week,
the
but it's
homework?
worse.
This homework paper.
Huh?
So you need to bring this with you completed to next class. Now, because that, I didn't talk fast enough, I guess.
Yeah, no.
You didn't get done in time for you to do the Desmos. So what I'm gonna do is I'm gonna give you some time to work on this, and I just wanna walk around and check on your notebooks that you've been copying the I can statements and those things. Wednesday, we'll do the 4th warm-up, and then on Friday, we'll do the last warm-up. You'll turn that warm-up sheet in. The intro to different notations, I need that paper because I need to start recording some minor grades for you. So when I come around to check your notebooks, if you will have that paper ready to turn in to me.
Intro to
Be
what?
sure your names are on them. And
Where's
then,
that?
so
Intro
you
to
can just
what?
spend these last
Got it.
15 minutes
Oh shit, we didn't do
going
it.
ahead and working on this homework. And
Can I get it?
first thing, next class, we will do your Desmos. So let me write myself a note.
Awful. Awful. Awful.
This is the 6th period.
Hold on, I need to follow you on this. I think I followed you, right? No, I not followed you? Oh, you didn't do it? Damn, tough luck.